Hey everyone, welcome back. Today's video tutorial is about a new sensor. It's a light sensor ISL29003. To gain more knowledge about this sensor, let's have a look over the website, that is controleverything.com, and here search on the sensor. Now let's have a look over its sensor. That's ISL29003 Light Sensor with Programmable Gain 0 to 64K lux. Now as you can see, these are some of its features. Also you can purchase the sensor from here. You can add to cart here. So for now I will be interfacing the light sensor ISL29003 with a particle photon and a particle code. To get the particle code, go to the resource tab, and from there you can have the code as zip file from this very site, from here. Now you can also have the code from GitHub repository, that is Control Everything community. Now get over it, and now what we require is to collect some hardware along with the sensor and make some connections for the interfacing and the working of this sensor. In the hardware section, first of all we require our sensor, that is light sensor ISL29003. Now this here is a particle photon and this is a shield, I2C shield. It's available and can be purchased from the website controleverything.com, and we are using it to make connections with other I2C devices, and that connection should be a lot easier. That's why we use it. Now gently place the particle photon over the I2C shield and make a connection. Now the binding factor is this, a connecting cable, which is to bind a connection among the sensor and the shield, and this is how it to be done. Now while making this connection, a rule has to be followed that the brown wire of the cable should be connected to the ground terminal of the sensor and similarly to the shield. Now we are done. The final part is to power up the particle photon, and for that we need a micro USB cable just like this and gently insert it over the power jack. Now we are done with the connections and we are completion for that. Now what we require is the code so that we can interface, and later on we will work out. Now for the interfacing of the photon with the particle code, what we require is to log in to github.com, and here we have to search for the repository, that is Control Everything community, and there you go. And here we have to search for the sensor, and here it is. It's a light sensor and this is the particle code we are talking about. But let's have a look over the instructions we need to follow. You have to log in to particle photon and set up the device according to the steps, and the steps are being provided on this very link. Let's have a link view over this link so that you can have a better idea how to proceed. Now as you can see, all the relevant information to connect, how to connect, and there you go. And next part is to download and copy the code on the online ID, and build.particle is the online ID where you have to paste the code, and after that you have to save it. Here we have to paste the code and here save it. Now the last part is to verify and flash the code on the particle photon, and this is dashboard.particle will help us to have the output on the screen like that. Now what we require is to have a closure watch over the code, and as you can see it's a .in extension file. First of all we have included application.h and spark wiring I2C.h header files, and we have defined the address of the sensor, that is 0x44. Now we have initialized a variable as you can see and created some of the variables, set them, and in the void setter function we have initialized I2C communication and serial communication with baud rate equal to 9600. Now in the writing part we have selected control list of having address 0x00, and the command here we have to send is to for selection of normal operation, as you can see 0x80. Next we have to select control list of having address 0x01, and we are sending a command to set the range, that is 64K lux, and the writing command is 0x0c, and there is a delay of 300 ms. After the delay we have to read the data back in the void loop function. As you can see, we are calling conversion result register, and there it is 0x04, and we are requesting 2 bytes of data, as you can see, for the luminance, and we are converting the luminous data as according to the details provided in the data sheet. At the very end of our code we have the output data on the dashboard for ambient light luminance, as you can see. And now what we require is to show the working, the practicality of this code along with the sensor and particle photon. So let's have it. Now for the practicality of this code, to show the working. First of all, copy this entire particle code. Open up the build terminal here, as you can see on my screen. Here, create a new file ISL29003 and paste the entire code and save it. Now verify and compile the code, and it's good to see that it's verified. Now flash the code. While flashing the code, we have to check for the magenta flash, and its notification is here. It will show that code is good to go and we can have the output on the dashboard. So let's have it. And in the dashboard user logs, we can have the output data on the screen. And here you go, you can have the ambient light luminance, and it's almost constant. And when I move some object over the sensor, you can see the decrease in the ambient light luminance, and it's further decreasing as I move closer the object to the sensor. But instead, when I bring some light source near the sensor, there is an increase in the ambient light luminance, and when I move closer the light source near the sensor, you can see and observe the change in ambient light luminance. It's going on further increasing. That's correct, like this. Now what do we require is to show the applications and the benefits regarding the sensor ISL29003. The ISL29003 is an integrated light sensor with a 16-bit integrating type ADC. I2C user selectable programmable lux range select for optimized counts per lux, and I2C multifunctional control and monitoring capabilities. The internal ADC provides 16-bit resolution while rejecting 50 Hz and 60 Hz flicker caused by artificial light source. It's applicable in a lot of applications such as ambient light sensing, backlight control, temperature control systems, camera light meters, lighting controls, and a lot many. Now you can purchase the sensor from the website controleverything.com, and you can have the code from the resource tab. After clicking on the resource, you can download the code as a zip file. You can also have the code from github.com, and the repository there is Control Everything Community. In the end, I would just like to make it clear that any part, if you have any issues, you can have your queries on controleverything.com, and you can post your comments on community page. For articles and blogs, you can have a look over instructables.com for us. And to subscribe more video tutorials like this, you can go to our YouTube channel. I hope you enjoyed this video, and thanks for watching.